all to do an activity on Desmos in which you're investigating translations. Okay, you guys know from before that a translation is essentially just what kind of emotion? A slide, thank you. Okay, so we're just sliding things. Something new we just talked about. Okay, was how the coordinates change as we're doing these translations. We discovered while we were doing this investigation, if you're moving to the right, what are you doing with your coordinates? Or what are you doing with your numbers? Adding them. If you're moving up, what are you doing? Adding them. If you're going to the left, you are subtracting them. And if you are going down, you are. Okay, so we're going to take some formal notes on this now, and there's a little bit of vocab in here that you need to know. The first word you need to know is pre-image. What does pre mean? Before. Okay. So the pre-image is what you start with before. So it's before you do any kind of a movement. So you're typically always given your pre-image. When you do your transformation, which in this case we were doing all translations, okay, that answer or that final thing you draw is called your image. So the first one is your pre-image, the second one is your image. How do I know the difference between the two? Okay. The pre-image has the regular lettering there, okay, for the points. The image has these little tick marks at the top. We call them prime symbols. So this would be called A prime, B prime, and C prime. And what that denotes is that there was some sort of transformation that occurred. Okay. The reason why you want to keep it as A, B, C is because a transformation is going to preserve the figure, meaning the same shape is still going to be there and it's going to stay the same size. So your image and your pre-image will always be congruent. Does that make sense? Okay. I will tell you a fancy name for a transformation that keeps congruency. Is called an isometry. A transformation that keeps congruency is called an isometry. So let me ask you this question. We talked about 4 different transformations in general at the start of this section. We had our translation, our reflection, our rotation, and our dilation. Out of all of them, which one would be the one that is not an isometry? Right, why?
Because it's not.
Right, why? Right, you're changing the size. It's same shape, but you're changing the size. So all the rest of them are isometries. Okay, everybody got this stuff copied down? There we go. Okay. Okay. Some books refer to isometries as rigid motion. So they're kind of like the same thing. Okay. So we can use the words isometry and rigid motion synonymously. Right.
So isometry is just any movement that doesn't change the size.
Right. It preserves congruence.
Dilation.
And we're only doing translations, but this is like the intro, and now we're going into translation specifically. So after we do translations and practice them, then we're going to move to reflections. Then after reflections, we're going to move to rotations. After rotations, we'll move to dilations. All right, so the first one that we investigated today is our translation. That's our slide. Okay, which essentially you're just going to move it horizontally and vertically. I would say it's probably the easiest out of all of them. In your investigation, you looked at the coordinate notation. What this is basically saying up here is you're taking your original coordinates, x and y, because remember, each point has an x coordinate and a y coordinate, and this is going to tell you where it's shifting. H makes sense because it stands for horizontal. And then they used K to represent the vertical. The reason why they didn't use V is because V stands for something else in math. Just like we use M for slope instead of S, because that stands for something else in math. Did you guys know that M, I don't know what the word is, but the reason why slope is labeled as M, because the Latin word for slope begins with M. That's kind of where that came from. No, the Latin word for slope, whatever that word is, I don't know what it is, begins with the letter M, and that's why they adopted M to represent slope, since S was already used for something else. So that's, I mean, same kind of concept, that's why we have a K there. V was already used, so it's K. Okay, and you can see over here a little hint. Always do your X's first when you're doing your movement, so you want to move horizontally left or right first, then you're going to move up and down. Left is negative, right is positive, your up is positive, down is negative. I don't really think it's going to hurt you. But I just suggest using X first, so that's typically, like, alphabetical order, you go that way. And then the other thing, too, is if you continuously use X first, you remember to list your X first, then your Y. You don't want to list it backwards, because technically that's wrong notation. Can I switch?
Yeah.
All right, so let's do some. So first, I need to draw the rectangle, and then I'm going to translate it. So my first rectangle is Q. 1, 2, 3, 4, 5, 6. Down 1, 2, 4 again. Let's try that point again. All right. 1, 2, 3, 4, 5, 6, down 1. And label it Q. And then my next one is -3. 1, 2, 3, up 1. That's R. And then S is 1, -5. And T is -2, -7. All right, and then connect your points. There's your rectangle. Here's my translation rule. It says I want to move everything +5 and +7. Well, that's pretty easy, right? So what can I do with all of my X coordinates? Add 5 to it. So -6 + 5 would be -1. -3 + 5 would be 2. And 1 + 5 is 6. And then -2 + 5 is 3. Okay, then for my y's, what am I going to do to every y? Add 7. So -1 + 7 is 6. 1 + 7 is 8. -5 + 7 is 2. And -7 + 7 is 0. So they're the coordinates of my new figure. Okay. So if you have coordinates, that's all you got to do. Okay, I think you guys kind of figured that out through the investigation. If you have the picture, you can just count them. So +5 means right 5. +7 means up 7. And just do it. Right, 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6, 7. That was my R. So when I label it, I do R with the little prime symbol. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7. Q with my little prime symbol. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. C prime. 1, 2, 3, 4, 5. 1, 2. Yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 7, S prime, and then connect. And all we did was shift our figure. To the right, 5. I'm not the best teller. And I'm 7. Okay. Questions? Well, I see my point at 3, 0. I see 6, 2. I see negative 1, 6. And 2, 8. It's just probably the way I drew it. Alright, second one is a triangle. Without even drawing anything first, let's just use our rule. We're going to subtract 3 and add 8. So if I subtract 3 from all of my x's, right, I'm going to have negative 1. For D, we're going to have 4. For E, we're going to have 1. And then for my y's, I'm adding 8. So 7. And then 4, 4. And then 1, 2. All right. That's without doing any pictures. I draw my original figure, 2. So, 2, negative 1, better. There's my C, 7, negative 4. There's my D, and E is 1, 2, 3, 4, up or down 6. There's my first triangle. And then when I move it, the negative 3 means I'm going to the left 3, and the plus 8 means I'm going up 8. So, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 4, 5. And there it is. I know that seemed really long, but I wanted to do it both ways because you need to be able to do it both ways. If I give you a graph, I want you to be able to slide it. If I give you just the coordinates, I want you to be able to work with the coordinates to tell me where it's going. Any questions with that? All right, so the next word I want to talk about is a vector. Okay, both have words for you to fill in there.
Wait, do you want us to do 3 and 4 alone?
Yeah, we'll come back to that. Just skip to this. We use vectors a lot in translations. Okay, the vector is represented in the coordinate plane by an arrow. Okay, so you can see here it almost looks like a right because it has an endpoint. It has an arrow on the other end. Okay, where it starts is the part without the arrow. That's called your initial point. Where the arrow is, and in this case the arrow isn't saying it goes on forever. The arrow is just giving you a direction. Okay, that's your terminal point. So you do have a beginning and you do have an end. The arrow is just drawn there for directional. Okay. So this vector would be called PQ. Looks like the same writing as a right. Okay, but it's called vector PQ. The component form of a vector, it almost looks like an ordered pair. Okay, the only difference is you use kind of like side carets. So we know it's not an ordered pair, it's actually a vector, and it tells you where you're moving. So it's almost like a shorthand way of saying add 3 minus, minus 2. So the A is going to be your horizontal part. the B is going to be your vertical part. So when you're doing your horizontal part, if you're going to the right, it's positive. If you're going to the left, it's a negative number. If you're going up, it's a positive number. If you're going down, it's a negative number. So if I look here, the horizontal part here is 1, 2, 3, 4, right? And it's to the right, so it's positive. And my vertical component, I'm going up 1, 2, 3, 4, 5, 6, 7, right? My vertical component is positive because it's going up. So my component form would be 4, 7. So essentially, if you just saw this written and they said this is your vector, this is telling you it goes right, 4, up, 7. Does that make sense? All right, so we are going to write, or we're going to name the vector and write its component form. All right, so when you name the vector, you always want to start with the part that doesn't have the arrow. So in number 5, we're starting with W, and we go to B, you put the arrow over top, okay, and the component form of the vector. So we need the horizontal and the vertical. So my horizontal is 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to go over 9 to get over here. So 9 will come first, and we're to the right, so it's positive. And then we go up 1, 2, 3, again positive. So there's your component form of the vector. Okay? We got a different direction this time. What's the name of my vector?
B.
BA. We start at B, we go to A. So we're going 1, 2, 3, 4, 5 left. So it's negative, and we're going up 1 still, so it's positive. How about my number 7? What is it? SR, good. And this time I'm going to the left 1, so that's -1, and I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Questions, guys? I'm going to leave those other 3 there for you. And we'll stop there. So what's for homework?